1902, Montana. Barnum Brown hacks through ancient rock and stumbles on a monster skull unlike anything seen before. The beginning of the myth we call Tyrannosaurus rex. Scientists declared it the king, but more than a century later, almost everything about its life, its growth, its power, even how it was named, is tangled in scientific rivalry and outright obsession. The story you think you know is only half the truth. What did we miss in the bones? And who really uncovered the secrets of Earth's most infamous predator? The answers start where the legend was born. 68 million years ago, the land that would become Montana was a world in flux. Wide rivers snaked through dense forests of conifers and flowering plants, while humid air pressed down on sprawling floodplains. Herds of Edmontosaurus grazed in the open, their beaked mouths stripping leaves from low branches. Nearby, Triceratops moved in small groups, the adults' massive frills and horns forming an armored wall around their young. These giants shaped the landscape, trampling ferns and uprooting saplings as they searched for food and safety. In this ecosystem, every day was a contest for survival. Crocodile-like champsosaurs lurked in the muddy shallows, snapping at anything that wandered too close. Turtles the size of bathtubs basked on fallen logs, while smaller dinosaurs, ornithomimids and dromaeosaurs, darted through the undergrowth, always alert for danger. Above, pterosaurs soared, searching for fish in the winding creeks. Insects buzzed and chirped in the warm air, feeding on the lush vegetation and the remains of the fallen. The climate was unpredictable. Torrential rains could turn the floodplains into vast, temporary lakes, stranding animals or sweeping them away. Fires sparked by lightning would race through the forests, clearing old growth and making way for new plants to sprout. These cycles of destruction and renewal shaped the web of life, dictating where herds could graze and where predators could hunt. Here, Tyrannosaurus rex lived not as a legend, but as a fact of nature. It was the last and largest of the great tyrannosaurs, towering over the landscape at up to 12 meters long and weighing as much as 8 tons. Its senses were honed for the hunt, with forward-facing eyes for depth perception, a nose packed with olfactory bulbs for tracking prey, and a skull built to crush bone. T-Rex was both hunter and scavenger, stalking the riverbanks for wounded Edmontosaurus or picking over the remains of a fallen Triceratops. Its presence cast a long shadow over the Cretaceous plains, shaping the lives of every animal in its territory. Yet even this apex predator was part of a delicate balance. For every T-Rex, there were thousands of herbivores, each playing a role in the slow dance of growth, death, and decay. Fossil evidence suggests that, at any one time, only about 20,000 adult T-Rex roamed North America, a rare predator in a world dominated by plant eaters. Over 127,000 generations, an estimated 2.5 billion T-Rex lived and died, but only a handful left their bones behind for us to find. This was the closing act of the age of dinosaurs, a world teeming with life, but always on the edge of disaster. The bones that would one day capture human imagination lay buried beneath mud and ash, waiting for the day when ancient rivers would become stone and the king of the Cretaceous would rise again in the light of discovery. Barnum Brown rode into the Badlands of Montana in 1902, searching for something big. The American Museum of Natural History had sent him west with a simple mission to find fossils that would astonish the world. Brown, dressed in his trademark fur coat and derby hat, was already known as a relentless collector. But nothing in his career prepared him for what he uncovered that summer along the banks of Hell Creek. The dig was grueling. Brown and his team faced blistering heat, sudden storms, and the constant threat of rival fossil hunters eager to poach a prize. For weeks they chipped away at a jumble of stone and bone, uncertain what lay beneath. Then came the breakthrough. They exposed massive vertebrae, ribs thicker than a man's arm, and fragments of a skull unlike any Brown had seen before. In his field notes, he called it a monster that dwarfed every other carnivore in the fossil record. Packing the bones onto horse-drawn wagons, Brown shipped the partial skeleton back to New York. The American Museum of Natural History buzzed with excitement as workers uncrated the remains. The skull alone measured over 4 feet long and was lined with teeth the size of railroad spikes. Brown's letters home brimmed with awe and a touch of showmanship. He wrote to his colleagues that he had found a creature rivaling any living or extinct animal in power and ferocity. The scientific world took notice. Henry Fairfield Osborn, the museum's president and a paleontologist in his own right, studied Brown's find with care. In 1905, Osborn formally named the new dinosaur Tyrannosaurus rex, which means Tyrant Lizard King. The name captured the animal's imposing presence and set imaginations racing. Osborn published his description in the museum bulletin, highlighting the skeleton's massive build and bone-crushing teeth. He compared it to another specimen, Dinosaurus imperiosus, but quickly realized they were one and the same. Tyrannosaurus rex became the official name, and the legend was born. Brown's discovery arrived at a time when museums competed fiercely for fossils. The bone wars of the late 1800s had left a legacy of rivalry and spectacle. Brown's Tyrannosaurus rex was more than a scientific find. It was a trophy and proof that the American Museum of Natural History could claim the king of dinosaurs for its halls. The skeleton was soon mounted in a pose that towered over visitors, cementing Tyrannosaurus rex as the face of prehistoric power. Through Brown's persistence, the world met an animal that seemed to belong to another universe. The discovery was more than bones in a box. It was the spark that turned Tyrannosaurus rex from a buried secret into a household name, setting off a wave of fascination that would last for generations. Tyrannosaurus rex was built for dominance. Stretching up to 12 meters from nose to tail and weighing as much as 8 tons, its body was an engine of raw power. The skull alone could reach 1.5 meters in length, packed with teeth up to 30 centimeters long, serrated, thick, and perfectly designed to puncture bone. Each tooth cycled out every 1 to 2 years, ensuring a lifetime supply of fresh blades for feeding. The jaws delivered a bite force estimated between 35,000 and 57,000 newtons, enough to shatter the bones of even the largest prey. But T-Rex was more than just muscle and teeth. Its senses were among the sharpest in the animal kingdom. Forward-facing eyes gave it depth perception, allowing it to judge distances with uncanny accuracy, a vital skill for a predator that needed to strike with precision. Large olfactory bulbs filled its snout, granting a sense of smell strong enough to track wounded animals for miles across the floodplains. Studies of the inner ear suggest it could also pick up low-frequency sounds, perhaps the distant footfalls of a herd or the calls of other dinosaurs echoing through the forest. Despite its size, T-Rex was no lumbering brute. Its hind legs were thick and muscular, supporting its massive weight and propelling it at speeds up to 15 miles per hour. While it couldn't outrun the fastest prey, it didn't need to. Fossilized trackways hint at short bursts of speed, enough for an ambush, not a chase. The long, heavy tail acted as a counterbalance, keeping the animal stable as it walked or lunged. Its tiny arms, often mocked for their size, were actually strong and likely used for gripping during feeding or rising from a prone position. For all its power, T-Rex was rare. At any given time, only about 20,000 adults roamed the continent. That scarcity meant each new fossil find is a window into its life, revealing how it grew, hunted, and survived. Its ecological role was complex, both predator and scavenger, capable of bringing down a hadrosaur or stripping the carcass of a fallen triceratops. The design of T-Rex, its size, senses, and movement, was a blueprint for survival at the top of the food chain, shaping not just its own fate, but the destiny of every creature that shared its world. In 2026, a new study rattled the foundations of what scientists thought they knew about Tyrannosaurus rex. Holly Woodward, Nathan Meervold, and Jack Horner published a sweeping analysis of 17 Tyrannosaurus rex leg bones using a technique called histology, slicing bone thin enough to reveal growth lines much like tree rings. For decades, the dominant theory said Tyrannosaurus rex rocketed to full size in a teenage growth spurt, reaching adult mass in less than 20 years and living only to about 30. But the new evidence pointed to a different story, one of slow, flexible growth stretching over 40 years, with some individuals living as long as 50. The team's approach was both old school and cutting edge. They counted lines of arrested growth under polarized light, then used advanced statistics to stitch together growth records from different size specimens. The result was that Tyrannosaurus rex did not race to adulthood. Instead, its growth rates waxed and waned, shaped by environmental ups and downs. Some years showed thick bands of bone, others nearly vanished, hinting at droughts, food shortages, or even social pressures. The old model of a dinosaur sprinting through adolescence gave way to a picture of resilience and adaptation, with T-Rex enduring the unpredictable rhythms of the Cretaceous. Not everyone agreed. Gregory Erickson, a longtime advocate of the fast growth model, pushed back, citing earlier work on dinosaur metabolism and protein sequences that seemed to fit a rapid rise to adult size. He argued that bone chemistry and collagen pointed to a more mammal-like growth curve. The debate spilled into academic journals and conference halls, with each side dissecting methods and challenging assumptions. Some critics questioned whether all growth lines could be trusted. Were they truly annual, or could stress or disease create extras? Others wondered if the sample size was big enough to capture the full range of T-Rex life histories. The debate was intense and methodical. The controversy only deepened when the same statistical tools flagged two specimens named Jane and Petey as outliers. Their growth curves did not match the rest, fueling a parallel debate over Nanotyrannus. Were these small-bodied tyrannosaurs truly a separate species, or just unusually slow-growing T-Rex juveniles? New papers from rival teams poured in, some arguing for coexistence, others for ontogenetic variation within T-Rex. The lines between species, age, and individual difference blurred, leaving paleontology in the thick of an uncertain scientific crossfire. Through it all, one thing became clear. The story of Tyrannosaurus rex was far from settled. Each bone held a record not just of size, but of struggle, years of feast and famine, injury and survival. The king of the dinosaurs was no longer just a symbol of brute force, but a survivor shaped by time, chance, and the shifting fortunes of a lost world. In 1993, the release of Jurassic Park sent a shockwave through popular culture. Steven Spielberg's film did not just break box office records. It transformed Tyrannosaurus rex from a museum centerpiece into a global superstar. The dinosaurs' roar, its chase scenes, and even its famously tiny arms became icons overnight. Paleontologists like Jack Horner consulted on set, but Hollywood took liberties, exaggerating features for drama. Audiences did not mind. They left theaters wanting their own piece of the king. Toy companies and model makers rushed to meet demand. Within a year, T-Rex figures filled store shelves, from plastic snap-together kits to roaring animatronics. The global dinosaur toy market ballooned, topping $1 billion a year. Museums saw crowds surge, with children dragging parents to see fossil hauls. The Field Museum in Chicago became home to Sue, the most complete T-Rex skeleton ever found, discovered by Sue Hendrickson in 1990. When Sue went up for auction in 1997, the bidding war was fierce. The final price was $8.36 million, a world record at the time, paid by a coalition of museums and corporate sponsors. Sue's arrival in Chicago drew national headlines and a parade. Collectors, too, joined the frenzy. Fossil hunters scoured the Badlands, hoping to strike it rich. Landowners in places like South Dakota found themselves at the center of legal battles and multi-million-dollar deals. In 2020, Stan, a a 70% complete T-Rex went under the hammer at Christie's. The skeleton fetched $31.8 million, more than tripling Sue's record. The buyer remained anonymous, sparking debate about whether such treasures should reside in private hands or public institutions. Some museums lost out, unable to match the deep pockets of private collectors and overseas bidders. The stakes grew higher as each sale set new records. For scientists, every lost specimen meant less access for research. For museums, the competition fueled fundraising campaigns and public appeals. For the public, T-Rex became more than a fossil. It was a symbol of wonder, power, and the high price of fascination. Movies, toys, and million-dollar auctions turned the ancient predator into a modern phenomenon, blurring the line between science and spectacle. No one has ever found a fossilized T-Rex nest, let alone a pair caught in the act. The truth is, almost everything about how Tyrannosaurus rex mated remains a mystery. Scientists can only infer the basics from bones, growth rings, and the habits of distant relatives. What we do know is that T-Rex likely reached sexual maturity in the middle of its life, perhaps around its early 20s, based on the spacing of growth lines in leg bones. This matches patterns seen in modern reptiles and birds, where rapid growth slows as individuals become old enough to reproduce. Hints about reproductive behavior come from mass bone beds of related species, like Albertosaurus, which suggests that some tyrannosaurs may have gathered in groups, possibly for mating or protection of the young. But for Tyrannosaurus rex, direct evidence is missing. Eggs, nests, and even clear differences between males and females are absent from the fossil record. The best clues are indirect: the size of pelvic bones, the timing of growth spurts, and comparisons to living animals. Some paleontologists speculate that, like crocodiles or large birds, T-Rex may have performed courtship displays or fought for mates, but these ideas remain untested. While the mysteries of T-Rex reproduction spark endless debate, the question of bringing one back to life is settled by chemistry, not imagination. DNA, the genetic code needed for cloning, is a fragile molecule. In 2012, scientists measured DNA decay in MOA bones and found a half-life of just 521 years. After about 6.8 million years, even the best preserved DNA strands would be gone. T-Rex vanished 66 million years ago, 12 times past that limit. Claims of dinosaur DNA in ancient bones have never held up to scrutiny, and what is left are only fragments of protein, not enough to read or rebuild a genome. Modern gene editing tools like CRISPR have fueled talk of de-extinction, but these projects focus on animals with surviving DNA, like mammoths and passenger pigeons. For dinosaurs, there is no template to edit, no sequence to patch together. At best, scientists can try to tweak the genes of living birds, the closest relatives of Tyrannosaurus rex, to highlight ancient traits. But this is a far cry from resurrecting the king itself. The dream of cloning a T-Rex belongs to the world of movies, not science. What remains is the fossil record, a silent witness to a world that can never be revived. Today, T-Rex fossils fetch millions and ignite global debate, yet every new bone or scan rewrites what we know. As technology sharpens, the mystery grows richer, not smaller. Our fascination with this ancient predator isn't just about the past. It is a mirror for how we chase the unknown. The king may be extinct, but the questions are very much alive. What will the next discovery reveal?